All right, so the next part is setting up for both cut um, and surfacing. Now, what I would do if I were you is separate the two files into two layers. So let's do a cut layer. And then you see we have some additional pieces out here. If we get any of that, just trim them off. Now, we might have duplicate layers, so we don't want the Sharpie to draw things 10 times. So if we do select dupe, that'll select all the duplicate layers. We will get sometimes duplicate layers with that project. And then delete them. Okay, so select dupe, make sure you do that. Otherwise your Sharpie will be like, why is the Sharpie drawing over the same line 10 times? Okay, you'll be wondering. It's because there's 10 lines there. Okay, so SELDUP will select any duplicate lines in a position. And then we'll make a, let's make a Sharpie layer. Sorry. So we'll put this on a Sharpie layer. So again, this is important, guys, because we don't want to have other stuff on, okay? So we have to make sure in the end we just have what we need. Okay? So in this case, it's these two layers. Now again, you have all the parts. I just have this one part for right now. Alright? So you're going to have your Sharpie layer and your cut layer. The next thing is that we're going to do is draw a rectangle. So sometimes it's good just to make like a some type of layer for the box, bounding box. And this is going to be our sheet size. So we'll draw a rectangle, 0, 0, and then 48 inches, 96 inches. Alright, so that's our material size. So you always want to have this as a guide, because this is how our material is going to be figured out, okay, in RhinoCam. So it looks for like, so this is very important, guys. If you have stuff floating like 5 feet in the air, it will try to move the tool in the Z 5 feet. And you'll get to witness the thing raise up, bust off, and fall. It'll be like, you know, and just come out and fall on the table if you're the most unlucky person. Okay, because you turn off the stops. Remember, you turn off the soft stops. So if it goes past its limit, it'll keep on trying to go. Okay? So be aware. Okay, when you look at this thing, make sure it's not going up more than what, you know, it's supposed to go up over the surface, which is like an inch or something to do its path. Okay, this is critical. Not only will you not finish cutting your piece, you will be escorted out of the building by John, okay, or myself, so if I'm happy to be there. So please, when you're doing this, guys, act like you're surgeons, all right? You can lose the patient. All right? There might not be lives at risk other than your own. So, you know, you can get hurt too. So be really aware of what you're doing, okay? So So if you're not confident, like if you think you have stuff floating in La La Land, just select what you see here and say invert, and just type in hide. Yeah, there was no objects, all right? So that's good, all right? So you want to make sure there's nothing floating in space, all right? Then we're going to go to RhinoCam. All right, the first thing that we're going to do is get the stock. So we'll go to stock. So guys, I want you to do that. You can do this all here. RhinoCam works here, all right? I prefer you to do it here rather than show up there and then go, oh wait, all my lines are, I gotta spend a half hour now and fix everything. All right, so please. If I can get this thing to think. Come on. So we're going to do our box stock. Always we're at the, I always like Z top, so we go Z negative. This is going to be set to 0, 0, 0. Okay. Our piece is 48 by 96, and we're using 0.04. Okay. You can just do plus because we're telling the top is here, so it's going to go negative. Okay? Because we put it, we're locating this as our top material, it'll go negative 0.04. Make sure you're working in inches or in feet in inches, okay? And then hit OK. So you saw our box material there. So it's going down 0.04, okay? All right. The next thing is, you got to make sure your piece fits, right? So, we're putting screws at the corners here and here, at the midpoint there, and then at the top there and there, right? So you have to make sure that your piece isn't sitting where it needs, where there's a drill about to hit a screw head, right? If that drill bit hits the screw head, drill bit will lose, screw head wins, yeah? So you'll chip the bit, it'll be ruined, they won't be able to cut, you just bought yourself a destroyed $30 bit, okay? So be aware of where your screws are. And we remember on the machine, we always sort of can see that and sort of move X, Y to make sure we're not in a critical moment. Again, you have multiple pieces, you want to make this as big as possible, okay? So scale is important here. In this case, obviously I don't have just one piece, but we definitely can probably lay this out. So you're going to be packing this manually. And again, you want to be careful to scale everything equally. All right, so uniform scale, make sure they're all scaled the same size. All right. All right, so let me delete this one. Because you never can really, you can just cut them. It's always weird. You can't delete, you can only cut them out. You just don't repaste them. All right, so a couple other things. If we come here to post, we can do this later, but if we right click on this, we want to make sure we set this to current post processor. It's the Shop Saber Win CNC ATC. This is the correct format for our machine. And then we're going to start setting up our different machining operations. If we look at 2D, we will have engraving. This is what our Sharpie can do. So all our Sharpie paths will be set up as engraving. With engraving, the bit actually runs down the center, okay? So it will run down the center. With profiling, if this is our sort of edge, our bit is always offset from one side or the other. So when it cuts, it's cutting away this material. This is our bit edge, right? Where engraving the tool runs right down the middle. Okay, that's the difference between engraving and profiling. So in this case, the Sharpie's a little bit on an angle. It's not just straight down. It'll be like the tool holder or something like this, and it'll run down that middle. Okay. So, and it won't be spinning. So we'll look at. We won't be spinning it, obviously. So the spindle speed will be off. But again, we'll investigate that on Thursday, and I'll make sure that that's working. So engraving. It asks us. Sorry?
If we spin it, it's going to get flat.
I think if we spun it, it might spin off.
Okay.
I know what you're trying to say, but like, might catch on, might just eat away the tip. But yeah, I don't think we want to spin it. So we select in this case, all these lines, except for the red lines, right? So I can use my layers to turn that on and off. Okay. Tool doesn't really matter. Feeds and speeds will matter. So if we set our speed to 0, well, let's load from tool. Sorry, load from file. Our spindle speed. So if we put this at like, I don't know how fast we'll be able to run it. We might be able to run it all the way up to 200. We'll see. I know they're testing it for us, so we'll be cutting. It'll be running at 200. I think that it'll be probably pretty fast, but there's a lot of lines. We'll see. We'll test it on Thursday, okay? So I'll be there Thursday with you guys for the first group that comes in. And then I'll let you know exactly which speeds are working. And we'll talk to John. They've tested it already. And we put the spindle at 0. I'd hope that. And then we might have to just turn off the spindle when it tries to start up, okay? That should be about it, other than our cut depth. There'll be none. So our total top depth is like, how far do we want to go in? How hard do we want to push on the material, right? So again, we'll see tomorrow, but let's just say 0.01 for right now. So we can see our paths. We haven't generated this yet. So I'm going to right click and say regenerate, hit OK. So there's all our paths. We can simulate this. That's how we'll draw it. So again, these will just be Sharpie markings, okay? So you're doing your whole thing, your whole piece Sharpie. After that, we do our profiling, okay? So then we're going to go to 2D again and go to profiling. We'll remove all regions. And in this case, we're just going to select our outside cut. Our tool, we are going to be using a flat. It's going to be 1/8 inch. And tool diameter is 0.125. We're going to save this as a new tool, flat mill, hit OK. So this is what we're going to be using, okay? Feeds and speeds, those we know. We're running the spindle at 6,000 and our speed was at 60. Oh, we kicked it up a little bit. Kicked it up about 120. Let's run it at 80. Okay, so our cut's running at 80. Sorry? It's just easier because if we just put the spindle speed and put the cut, it fills in the rest. So you don't have to. It just, it knows what to do for the rest of them then. So load from file, we just give it the spindle speed and the cut. And then it knows what to do for plunge, approach. So it just fills it in for us. Clearance plane, we don't have to touch, automatic. Cutting parameters, this is where if we're going to be inside and outside, I like to just flip the lines if they're not working. Total cut depth, so this is the tricky part because that, now supposedly we're going to have a new spoil board, so it's going to be really flat, okay, or it's going to be ready to go. So I'll verify that with John today. So new spoil board, which means we should be cutting around 0.04. Right? So we might have to increase that to make sure we're going all the way through. So that's typically our cut of the material. Entry, exit, make sure we put none on these. Advanced, we do want to create bridges. Let's make these a little bit taller so we can leave them at 1. Sorry, 0.1. And then we'll make the length, I think we made them 1/2 inch last time. And that was working pretty good. I was keeping the material. Because the pieces are bigger, let's put 8 of them. So that's the number of bridges. Okay, those are easy to cut off. Alright, so we can save that, right click, regenerate it, hit OK. And now this is where we want to make sure everything's okay. If we see our tool go like up in the air and then come down, that's a problem. What does that look like? Well, if I go in my front view real quick and say I just make something up here, like I didn't realize I have this dude up there. And I'm working. And then I regenerate this. And I say, oh, why is my tool going all the way up there? If you see anything like this in red, that means the bit is trying to raise way higher than the machine can. Okay? Now we'll catch this when we put it onto the CNC machine and open the file and see, right? We visually look at the file. We then look at the limits, right? And the Z limits are critical. So if we're going more than negative 0.04, that's a problem. If we're going higher than probably like an inch or something, it'll show in red, there's a problem. So if those numbers get highlighted in red, that's a problem. So because we have this sphere somewhere in space, it's causing this issue. I can't even see it right now. Why is that sphere invisible? I even made it invisible. Must be tiny. No? It is tiny. It's like infinitely tiny. Okay, so if we delete that, I don't think I gave it a radius. I think I gave it a radius of 0. And then if we regenerate this, can see we're back down. Okay? So this is important. Make sure you do not have stuff floating in space. All right? All right, so let's look at our turn on our other two layers. Sorry. So we're going to right click and say post. And then I would, keep one as an engraving. It's not a bad idea. Make sure you know where you're putting them. And again, you can see our tool is set to 1. We'll see if we'll keep that or not, but you can see our spindle is set to 0. So our speed is set to 0. If we come here, we're going to post. And yeah, I apologize, but it's I sort of want to. That's maybe the profiling. And you can see now our speed is set to 6,000 for our tool. Okay. So we can combine these two, put them together, like copy one and paste it behind the other. We'll decide that. I'll let you guys know what we're going to do based on what happens on Thursday. Okay. So the idea is then, if I would open up your file, again, save down the Rhino 4, okay, because the computers that are located in the Idea Shop do not have 5 on it. I would open your file, probably export it out, get there like an hour earlier than your cut time, so you can sit on the computers, work on it. Things should be calm over there because iPro Day is Friday, so that means Thursday might be a little hectic, but probably not because it's already too late. So if people are trying to do stuff on the CNC machine at least. But we have a reserve, so it doesn't matter. But they might be a little hectic in the lab. So I will be showing up. So anybody sign up for the 12 o'clock spot that's here? I know some people signed up. I'll just send an email. I'll try to get there at least an hour to a half hour before. All right. Questions on this process, guys? This is pretty straightforward. So again, you're working with the model that you've retweaked. I would relay it out, unwrap it, unroll it, cut it, test it again out of foam if you can quickly. Okay. So in case you see something that's an issue, redo that again, then apply your patterns once you're confident, then unroll it again, then make your cut files, okay? And now we're going to look at the next part, which is going to be sort of the rendering output, all right? So again, you're going to be coming with your model, and again, I think we'll eliminate the whole painting. I'm not trying to torture you guys, but I'm trying to be realistic. I think if these guys came in, taped on the inside with the markings, that'll be enough. For those of you that want to take it further, because this person that want to take it further, we looked at a couple of options. One being actually using the Zap-A-Gap, so using it's basically it's a glue that's with different consistencies, like thin, medium, thick. You can buy those at Blick. So it's called Zap-A-Gap, and they have different thicknesses. If you get the thick version, you can fill in the gaps and fuse the material together, so the tape isn't doing the work anymore. Then it can either be sanded, all right? depending on how big the gaps are, if the gaps are really large, I'm talking to John, I think just caulking it, you can get a painter's caulk that's in the little tubes, and there's a sandable version of that. So, and it's flexible, so you can like fill in a lot of that. So we're not going to be using Bondo, obviously, because it's toxic. Bondo would actually be nice. That stuff dries also. But I think keeping it safe, using that painter's caulk, that there's a version that's flexible but also sandable. You can sort of cleanly fill in the laps with the little tubes, the little handle tubes, sort of caulk it, sand it after you glued it, and then you can paint it, mask it with the Sharpie lines, and then repaint it. But if someone comes in with that, I'll be, happily surprised. So the idea is that Sharpie, cut, assemble, yeah? So I don't want to see the tape on the outside. If you have to have the tape on the outside, that's fine, but I think it would be better if it weren't. All right? And if you have to have the tape on the outside, maybe do it much cleaner. All right? Maybe the whole thing gets taped on, right? Like this pattern. Have you seen the saran wrap pattern? You put saran wrap and made like a million out of it that you can climb into. It's like so strong as a material. If you like Google it, it's pretty cool. It was in Europe. It was in Berlin. Okay, let's take a short break.